Hello and welcome to Unit 8 Opener number 3. We'll be solving another system of linear equations here, and we're going to be solving it by graphing again. So you'll notice one of these two equations is currently written in slope-intercept form, so it's pretty quick and easy to graph. So I'm going to go ahead and graph this bottom one first because it's already in slope-intercept form. The slope will be 2 and the y-intercept will be -1. So I come down here and I start at -1, and then the slope is +2, so that means I go up 2 into the right 1, or I could go in the other direction, down 2 into the left 1, and I'm going to do that just a few more times to get a few more points on this line. Alright, so I graphed the bottom line, and now I'm going to have to do something before I'm ready to graph the first line. There's actually a few different choices you have for how to graph that line. If you were so inclined, you could just start picking values for x or for y and solving for the other variable. I think in this case the easiest choice though is just going to be, let's rewrite this equation in slope-intercept form. So I'm going to take this over here, I'm going to do a little bit of algebra to it. I'm going to take 4x minus 2y equals 2, and what I'm going to try to do is get this y by itself, and that way I'll have slope-intercept form. So in order to get this y by itself, first I'm going to have to get rid of this 4x over here. So in order to do that, I will subtract 4x on both sides. On the left side here, I'll have -2y, and then on the right side, I'll have 2 minus 4x. Of course, I can't combine these two because they're not like terms. Alright, well, I'm close to having y by itself. Now what I'd like to do is get rid of this -2, which is multiplying the y. So I'm going to divide -2 on this side, which means I have to divide this side by -2. And now I'm just going to do a little bit of simplifying. 2 in the numerator divided by -2 in the denominator will be -1. And -4x divided by -2 will be a +2x. Alright, so this equation looks like y equals -1 plus 2x. So I go back to my graph and I see the y-intercept is supposed to be -1. Interesting, that's the same point. And then I look again and this slope is 2. So I go up 2 and over 1, up 2 and over 1. Now if you haven't already noticed, as I'm putting these points right on top of the points that I already drew with the blue, this equation is actually the same thing as the equation we did in blue. So we couldn't really notice that at the beginning of the problem because they weren't written in the same form, but it turns out that these equations aren't two different equations, they're actually one single equation, and when you go to graph them, the two lines will lie right on top of each other. Alright, so there's a little bit of vocabulary that goes with this that we're going to talk about now. By the way, in terms of solving the equation, it turns out that any one of these points that lie, on the lines, since the lines are the same, I guess I can just say the line, any one of these points is a solution to this system. Because remember, a solution to a system of equations is a point that makes both equations true. So any one of these points makes both equations true. So it turns out there are an infinite number of solutions to this system, and the solutions are any point on the line, and you can choose any one of these equations you want because they're really the same thing. I'm going to say y equals 2x minus 1. So the solution to this system is any point on the line y equals 2x minus 1. And there are various other notations for how to write this. But I think we actually have some vocabulary that's more important for us to discuss right now. So let me talk about a little bit of the vocabulary that goes with this. So the first thing is the difference between a system that is consistent and a system that is inconsistent. What it means for a system to be consistent is that it has a solution or many solutions. So consistent means it has one or more solutions. This system of equations that we have clearly has one or more solutions. It actually has an infinite number of solutions. So our example is consistent. The opposite of that, of course, is inconsistent. Inconsistent. Which means that the system has no solution. It's worth taking a second to pause and just think, what does it look like for a linear system of equations to have no solution? So picture in your head two lines that don't intersect. What do they look like? Well, here's one line. Here's another line that doesn't intersect it. The only way those lines can't intersect is if they happen to be parallel. So in terms of linear systems of equations, they are inconsistent if the lines happen to be parallel. Okay, so that's one piece of vocabulary, is this idea of consistent or inconsistent. There's another idea we need to discuss here, and that is the difference between dependent and independent. All right, so these lines happen to be dependent. And in the case of a linear system of equations, that essentially means they're the exact same line. They are the same line. Now, when you get up to higher dimension things, this part is not necessarily true. But for our purposes today, we can think of dependent as meaning they're the same line. And so then independent simply means they are not the same line. Another way to think of this is that for a system that is dependent, all of the points that make one equation true also make the other equation true. And for a system that is independent, all of the points that make one equation true do not necessarily make the other equation true. So if we think about our system here, do we think this is dependent or independent? Well, they're the same line, so that would be dependent. So we would classify this system of equations as consistent and dependent, and the solution is any point on the line y equals 2x minus 1.